Hey everyone, thanks for joining this video. In this session, we're going to talk about building an operational data lake on top of BigQuery. I'm going to be telling you about some new features launching to a generally available state that can help you analyze your logs at scale. You're also going to be hearing from Home Depot and Goldman Sachs about how they've built log analytics solutions on top of BigQuery. I'm Christopher Crosby. I'm a product manager here at Google Cloud, and I lead our lake analytics product efforts. Now that includes everything from integrating BigQuery with transactional databases like Spanner and Cloud SQL, or creating better coupling with our Vertex AI platform. It also includes new ways to let developers write code against BigQuery using languages other than SQL, and of course it includes a lot of log analytics related capabilities like search and semi-structured data that I'm going to discuss in this presentation. So let's talk about operational data lakes. Now, what makes log analytics hard today is the complexity of the data systems that you're going to find in your typical organization. And a picture like this, while it seems kind of crazy, I've talked to a lot of customers, and this is kind of their setup. So you might have application logs going into something like an Elastic index. And then all of your application performance monitoring, it's done in Kibana. You have these APM dashboards and all that's well and good. Except then all of your lower level operating system and network logs for your SIEM and security, they flow into another system like Splunk. Then of course you have all of these other machine generated logs that you need to store in a format like time series. So you have a bunch of IoT data or sensor data that might be going somewhere that also needs to get downsampled, then put into a data warehouse. And then with all of this just comes a ton of overhead, and you definitely are going to pay an additional tax for having all of these different systems. So when I've talked to customers, there's essentially 5 critical issues that come into play here. First is the latency issue. All these additional hops means that data takes longer to get into the end systems. 2, there's not a clear source of truth. So data transformation, it might start happening in multiple places, and that makes it really a challenge to understand what's happened to the data. 3, trying to actually move to machine learning on top of this logging information just requires too many hoops, and the process really breaks down. 4, the reliance on just so many different interfaces. The same user has to jump from application to application. They end up with this host of tabs. They're trying to export data out, and all of this manual reconciliation just really starts to break down and becomes too hard. Now, even with those 4 pain points, and all that user pain, the IT teams that have to manage all this still have a really high cost and complexity of running and managing all of these different vendor systems. So by consolidating all this logging data under BigQuery, you can start to unlock a new set of use cases that may have just been simply too hard to perform by trying to look across all of these different point logging solutions that were really designed for one purpose instead of analytics on all of your logging data. So a DevOps team, they might be able to now quickly troubleshoot an issue by looking at the top count of requests and group those and aggregate those. And a security team, they might now be able to go back and look at the audit records for a particular user, not just in the last day or 30 days or whatever your current logging system can maintain, but over years if need be, because it's all can be stored efficiently in BigQuery and accessed with a simple BigQuery SQL statement. And then IT ops, they can now start to identify more network issues, because when you have services like GKE, emitting all these VPC flow and firewall logs, that logging data is very verbose and can add up quickly. And so having something like BigQuery that can handle that and query against that is really an asset. Now, to help our customers that wanted to go build these operational data lakes, BigQuery has made some features that are now generally available to help with all this analytics on log data. First is native JSON, second is search indexes, and then the storage write API for ingestion. That one's been out into GA for about a year, but let's focus on the first 2. So the JSON native data type now launching into GA. This native JSON data type, it's going to offer some new JSON functions, because chances are if you're working with logging or some logging data, it's going to be semi-structured, it's going to be changing, you're going to need flexible schema evolution, you might not control the downstream applications, you want this data to be able to come in fast and have a streaming ingest for it. So if you turn your data types into a JSON native data type, BigQuery storage is going to go and try to optimize both the cost and performance of all of those JSON SQL queries for you. Some new enhancements as we move to GA. First of all, there's batch loading. So now we support loading from CSV, Avro, Parquet, RSC, JSON delimited files, all the usual suspects that you would expect in BigQuery. And we've enabled a new ecosystem of connectors, whether you need to bring in JSON from Dataflow, JDBC, or Big Lake Tables, that's all now doable. And of course, there's some big performance enhancements that we've made along the preview as we now go to GA. So now that we're GA, you can migrate an existing table into this new JSON data type simply by setting the query destination to override when you run a query that casts your existing string JSON into a JSON. The example here on the right-hand side, that query can essentially get you right into the new JSON data type if you have JSON stored now as a string. Next thing I want to talk about is the new search functions and indexes that are also about to hit GA. So BigQuery search indexes, this is not an index outside of BigQuery. This is all right within BigQuery. You're going to use BigQuery standard SQL to go and find unique elements that might be buried in your unstructured text or JSON data. You don't have to know the schemas in advance. It can search across the table. Indexes are table-based, and you have cross-column search. The data is always accurate. You do not have to wait for data to actually get put into the index or worried about how any of that is managed. BigQuery takes care of all of that. And as soon as the data hits the streaming buffer, you can query against it in both a row lookup as well as have it accurate in your aggregations. Both work with the search. Some new enhancements as we go to GA, that we now have support for non-analyzed indexes. So by default, if you give us some free text data and tell us to index it, we will break that up according to some rules that we know about logging data. We have some knowledge around things like email addresses and IP addresses. But if you wanted to bring your own search terms and just use our index for the fast lookups, you can now do that with our non-analyzed index. We also have a new order by limit optimization for time series data. So if your data is in a time series format and it's partitioned by that time series column, and let's say you just need to return the top 30 rows as fast as you can, which is often a use case in these login applications. Just tell me what the most recent thing happened. We have a particular optimization that's designed for that. You can see it on the right-hand side, and some really massive both cost reductions and performance reductions that you're going to see from using that optimization with the search. So without further ado, you're now going to hear from two customers who are able to replace their existing Splunk and Elastic-based logging solutions with BigQuery. And they did that, and they've consolidated a lot of their operational data. That's reduced a lot of management overhead for them. They've started to tap into BigQuery for a lot more advanced analytics and machine learning functionality. And they've even been able to find new use cases by bringing together logging and business data. So, Jackson, why don't you take it over?
Hello, and thank you. I am very excited to talk to you about the Home Depot's enterprise logging platform, which is based on a combination of open source and custom stream processing applications with Google BigQuery Data Warehouse for storage and analysis, and the Looker BI tool for visualization, alerts, and reporting. My name is Jackson Pickett, and I've been a systems engineering principal with the enterprise telemetry team here at Home Depot for going on 2 years now. I've been with the company for close to 8 years, and I've been working in the enterprise logging space now for about the last 5 years or so. Our enterprise logging journey started with a very popular logging solution known as Splunk. Many of you have probably heard of it and probably have used it as well. Prior to that, we had a few different piecemeal or vendor-specific logging solutions in place, but nothing that I would really classify as enterprise. We found a lot of success with Splunk, but some major challenges as well. Serious effort was spent on the part of my team on performance optimization, which resulted in overall good performance and user experience. Unfortunately, however, the optimizations that they deployed relied in large part on high-end custom hardware, which resulted in some ongoing operational challenges for the team. User adoption was strong, with a ton of integrations and custom tooling developed and deployed in a very short time, and overall users were generally happy. But as engagement and performance improved, cost rose. Looking back, I think that a somewhat reactive approach to the architectural design drove a lot of complexity, and it got to the point where it became difficult for us to quickly respond to changing requirements from our business partners, as well as difficulty in justifying the growing expense to our leadership. And so we decided we needed to find another solution. And unfortunately, the strategy was accelerated somewhat due to some external forces as well. So with a compressed timeline, we started our search for a replacement and eventually settled on BigQuery as our storage backend and the Looker business intelligence tool as the front end and primary user touchpoint for the platform. This was chosen due to not only an attractive price point, but also very strong performance and usability, and also the added benefits, including enhanced self-service, which was a result of our reduced complexity, resource isolation, and RBAC capabilities, and also a reduced operational overhead driven by a shift toward modular cloud-based systems, as well as open source tools running on commodity hardware for our on-premise footprint. So how did we get there? Moving our unstructured and semi-structured log data into a columnar database such as BigQuery required a lot of in-flight data processing on our part, which was previously unnecessary, and we achieved this using stream processing based around Apache Kafka, which is deployed on-premise. We receive the log data at a set of custom log receivers arriving from a variety of different sources and over different protocols, primarily syslog, but also increasingly HTTP, which is used by our structured logging pipelines, as well as via our direct integrations with the on-premise platform as a service, which utilizes the somewhat creaky WebSocket technology for now. Once the data is received into Kafka, it is classified and transformed before getting shipped to the next hop in the pipeline, specifically Google Cloud Storage. This architecture allows us to export large batches of data out of the data center, typically about 10 megabytes per batch, roughly around 50,000 events per batch, and leverages cheap object storage configured as a de facto FIFO queue using pub/sub file notifications. This is a much more cost-effective strategy than shipping the data directly through pub/sub, and grants us massive parallelization capabilities which were not possible on-premise before we finally streamed the data into BigQuery. The end result of that design is our current state. Data requirements have only grown since the migration began, and currently we are streaming over 100 terabytes per day into 200 plus unique BigQuery tables for a total storage footprint of around 15 petabytes. 16 billion events per day flow through the Kafka streaming pipelines, where we are executing over 250 custom transformations and support over 500 user-defined log types on the structured side. Over 1,400 users in Looker have created thousands of unique dashboards, reports, and alerts using that data, which helps to keep our applications and systems up and running across Home Depot. Taking a peek at the front end, we can see that Looker gives our users the freedom to create custom data models known as explorers, extracting important fields and applying common aggregation functions to their log data, which can be used for ad hoc queries or added to dashboards or to trigger a critical alert, all in a self-service fashion. And in this slide, we can see an example of some of that user-created tooling, which is measuring traffic and error rates for our enterprise API gateway solution. Data like this can help to quickly troubleshoot and even prevent issues with the system and perform root cause analysis when those issues occur. Looking forward, we are hoping to migrate large portions of our on-premise infrastructure to GCP, including parts of Kafka and our custom processing applications. This should help to actually simplify our cloud-based architectures by eliminating the cloud storage persistence layer altogether, as well as enhance our data as a service capabilities by providing consumable data streams in the cloud. In addition, we hope to leverage the emerging BigQuery search index capability for enhanced user experience on our wide column data sets, which should eliminate some of the need for the more granular custom processing that we are doing today. In conclusion, I would say that overall we've been incredibly happy with the BigQuery Looker solution, not only from a cost perspective, but also in terms of performance, operational overhead, and most importantly, user experience. Thank you very much.
Hello, I am Chetan Mehendirata, an engineer at Goldman Sachs. Today, we want to talk about a unique problem that we were solving, which was solving a multi-cloud, scaled-out, cost-efficient, highly available logging solution. Like any large organization, Goldman Sachs relies on multiple clouds and on-prem data centers to deploy applications. We want to have a logging solution which is common across all cloud providers where all logs can go in. We also want this solution to be petabyte scale with more than 100 terabytes of logs ingested per day. And we want it to be a cost-efficient solution. In addition to that, the solution has to be highly available with at least 4 nines, since applications which are highly available depend on this logging solution for their logging needs. The solution has to be highly available with 4 nines of availability. And it needs to scale to high ingestion rates and high query scaling. When we started analyzing this problem, we obviously went with the familiar solution, which is Elasticsearch and OpenSearch. Having run this at the firm at scale, we knew certain problems would arise, and we were facing these certain problems constantly at scale. The first is complexity and data silos. Running Elasticsearch is hard because it is a model of combined storage and compute, which limits the scale and adds complexity with data silos, since ultimately you have to split your clusters into multiple clusters. Although you could run queries across multiple clusters, but it becomes increasingly hard with hundreds of terabytes of scale, hence creating data silos. In addition to that, it is a very cost prohibitive solution at certain scale because you're always sizing your compute at the peak load. And since storage and compute are combined, this adds to the complexity and the cost of the solution. We wanted to find a new way. So our new way was based on 3 pillars: a single scalable storage layer, a multi-cloud transport, and a presentation layer. For a single scalable storage layer, we wanted a scalable storage which could give us very efficient term search for needle in the haystack queries, could give us JSON support for our varied data set, and can combine streaming with at least every second ingestion with the goodness of cheaper storage model, which comes with separating compute and storage. On top of that, we wanted to ensure that we can do spike management, both in queries, and we can scale the solution when we have ingestion spikes. BigQuery was the solution that we chose for all these factors. The second problem we had to solve was a fully hosted network for routing all of our logs from on-premises, data centers, and all clouds. And we had to give our users a log agent that they can embed within their virtual machine or their containers. And we use a combination of Fluent agent for that purpose. Lastly, presentation, which is super important for any logging solution, is we chose Grafana, a combination of Grafana and Looker. Since Grafana is a common open source visualization tool for observability, we chose that, and we found a data source already available for BigQuery, and we contributed to that. On top of that, we used Looker as an advanced query language. Building a logging system, we had to do more than just these requirements. There are other very important things that we needed to solve. First, long-term retention. Goldman being a regulated entity, for certain data sets, we had requirements to save the logs for up to 7 years, and in some cases, shorter. So we wanted a variable but very extendable long-term storage layer. PII handling. We do not store PII in our logs, but as we all know, accidents happen. And we wanted a strong detection, handling, and remediation possibility. We intend to use Google DLP, which we have POC'd with, but we intend to use Google DLP for this purpose. IAM with delegation. One of the important requirements for us was, in the middle of an incident, if a developer wants temporary access to a certain set of logs with good break glass temporary access mechanism built in, they could solve the problem much more efficiently. That is something that we solve for. And last two are alerting on logs and query cost allocation. Although alerting is primarily done on metrics, but there are valid use cases where we had to support alerting on targeted logs. And we wanted to ensure that we can allocate the query cost based on the users where queries are originating. Finally, I would like to cover a use case, a concrete use case where this data actually came in very handy, or this mechanism came in very handy. Goldman has a proprietary distributed database called SecDB, which is spanned across thousands of servers. These servers get tens of billions of connections coming from 10,000 plus, several tens of thousands of servers across the globe. We had to solve two main problems. Problem number one is the real-time detection of saturation point, essentially finding a noisy neighbor and remediating it in real time. And second is a strong capacity management in near real-time query capacity so that we can manage the capacity of our SecDB database rings. With that, thanks a lot for your time.
So I want to thank both Home Depot and Goldman Sachs for sharing their stories about how they've been able to move their logging applications onto BigQuery. And if you're thinking, how could you go and get started trying to run your own log analytics solution on top of BigQuery, one suggestion I have for you is to try the log analytics solution that comes from our cloud logging team. This log analytics preview lets you easily analyze your logs using BigQuery. The preview gives you the best of both ecosystems, the power of BigQuery, but then combined with the purpose-built log analytics UI that's available in cloud logging. You can go and try that today by visiting the console link that you see in the bottom left-hand corner. Thanks a lot.